So this is the review for the Unit 6 test. First of all, it says, by Cavalier's principle, this right triangle prism and right rectangular prism have the same volume. If the center plane intersects a solid parallel to their bases, which of the following choices could be the base and height of the triangular cross-section? So the first thing I want you guys to notice is that these heights are the same. Y'all notice that's a height and that's the height. So what does that mean? That means our bases have to be the same. Okay, so our base area here is 1/2 base times height because that's the area of a triangle. Over here, the area is just base times height because it's a rectangle, right? So the area over here is 8 times 6, which is 48. Okay, so what we're looking for is how do we get the same base area in the triangle? So we're going to take the height in the base that's given to us in each of these problems, and we're going to compute it, and we're going to figure out which one is equal to 48. So let me go ahead and do that. So this is going to be 1/2 of our base, which is 12, times our height, which is 4. So that's going to be half of 48, which is 24. Well, that's not the answer we're looking for. We're looking for 48, okay? So here we got 1/2. Our base, again, is 8 times our height, which is 12. That's going to be 1/2 of 96, which that is 48. That's our answer. I'm going to do the rest just so you guys can see it. Okay, this is 1/2. Again, our base is 8 times our height, which is 4. That's 32. Half of 32 is 16. Not our answer. And some of y'all that picked up the review early, we changed those numbers from the same as B to different numbers, okay? So here again, 1/2 our base, which is 14, times our height, which is 8. That, if I recall, was 112. 14 times 1, 8, and half of that is going to be 56. So once again, we're looking for the same areas in the bases, okay? So number 2 says the space inside the box around the pyramid is filled with protective foam. About how many cubic inches of foam is needed to fill the space around the pyramid? So we need to find the volume of the cube. So the volume of a cube is equal to the length times the width times the height, right? And all of those are 5. So that's going to be 5 to the 3rd, right? So that's going to be 125. Now, the volume of our pyramid, okay, that's going to be 1/3 base times height. Well, our base is 5 times 5, right? And our height is 5. We're just going to divide that by 3, aren't we? Because multiplying by 1/3 and dividing by 3 are the same thing. So when we do this, this is going to be 41.67. And then what are we going to do with those two numbers? We are going to subtract them from, we're going to subtract the pyramid from the cube. And when we do that, we get 83.3. And it says round to the nearest inch. So our answer is going to be 83. Again, this is going to be inches cubed. All right, number 3 says, what is the total volume of the composite image to the right? Given the diameter of the cone is 8 centimeters. So if the diameter of the cone is 8 centimeters, then what is the radius, y'all? So that means if the diameter is equal to 8, we're going to divide that by 2 to get our radius, aren't we? Okay, and then it says the height of the cone is 2 times the radius. So the height of our cone is going to be 2 times r, which means that's going to be equal to 2 times, oh, I didn't write that answer, by the way, that was 4, right? That's going to be 2 times 4, which is 8, okay? So now we're going to compute the volume of the cone, the whole ice cream cone, okay? So it's because it says, what is the total volume of the composite image to the right? So, and it's not really an ice cream cone, but it sure enough looks like one to me. So, okay, so what we're going to do is we're going to do our hemisphere first. So we're going to find the volume of the hemisphere. Now there's 2 ways you could do this, and I'm just going to show you all the volume of a sphere and divide it by 2. 4/3 pi r cubed. That's the formula for a sphere, right? That's a sphere. Just keep in mind that whatever answer we get, we're going to have to divide it by 2, right? Okay, so let's go ahead and do this. I'm going to use a smaller pencil. Okay, so this is going to be 4 times our radius was 4 to the 3rd divided by 3 pi, and then I'm going to divide all of that by 2. Or 2/3. I could do 2/3 instead of 4/3 if I wanted to. So that means with a hemisphere, okay, we're going to get 42.67, and I'm rounding that pi. Don't round it to the end, y'all. Okay, so now if I multiply this by pi, which is what we're going to do next after we find the cone. Okay, so now we're going to find the cone. The volume of a cone is equal to 1/3 pi r squared, right? So that's going to be equal to 4 squared times pi over 3, right? Because you're going to divide it, right? So that's going to also give us, guess what? That's going to give us 42.67 pi again. So now we're just going to add those together because it's asking us for the composite volume. That means we want the volume of the whole thing. So when we do that, we get, what is that going to be? 85.34 pi. And then it says, round the answer to the nearest tenth of a centimeter. So when we multiply that, I got 268.1, and this is going to be centimeters cubed, right? Okay. Now, you could have computed each of these too, okay, and then added them together. All right, then the number 4 says find the value for each of x for each part. Okay, so notice that this is 158 here. So we're going to take that 158 and divide it by 2 because that's going to give us this angle right here. So that was 79 degrees, okay? Now, what I'm going to do is I'm going to add these two angles together because I know when I add them all three together, they have to equal 180, okay? So when I add 45 to 179, 45 plus 79, that's equal to 124. So then I'm going to take 180 minus the 124, and that's equal to 56. Then I'm going to take, so I know that this angle right here is 56 degrees, but it's not asking me for the angle, it's asking me for x. So I'm going to say 56 is equal to 7x minus 7. I'm going to add the 7 to both sides, so that gives me 63 is equal to 7x. Divide both sides by 7, so x is equal to 9 right here, okay? Now notice on this next one that we have half the circle here. Do y'all see that? This is a diameter, right? So isn't this equal to 180? It is. So that means this angle up here at F is going to have to be half of that, isn't it? So that means that's going to give us half of 180 is 90. So this is 90 right here. So we're going to do the same process we did a minute ago. We're going to do 90 plus the 55. That's equal to 145. And we're going to subtract that from 180. Okay? So that's going to give us 35, right? So that means this angle right here is 35 degrees, and that's how we're going to solve for our x. So 35 is equal to 3x plus 11. Subtract 11 from 35, that's 24, is equal to 3x. Divide 3x by 3 and 24 by 3, so x is equal to 8. So it says on the next one, find the values to the following in fractional in simplest radical form. Okay, so let's just talk about again what we see here. So I'm going to change the pi to 180 so that I can get the angle. So 180 divided by 3 is 60. So that means that's 60 and that's 60. Okay. 180 divided by 4, that's 45. And that's 45. 180 divided by 6 is 30. And this is 30. And by the way, this should be cosine. Okay. All right. Now, I'm going to draw a 30, 60, 90 triangle. We know what sine and cosine mean, right? Okay. So this is what we're going to do. Our hypotenuse here is going to be 1. Okay. This is our 30-degree angle because it's across from the short side. And this is our 60-degree angle because it's across from our long side. Now, what do we know about the short side as it relates to the long side? It's half of it, right? And then what do we know about the long leg as it relates to the short leg? It is the square root of 3 times 1/2, which would be the square root of 3 over 2. Okay. So there's a couple things I want to show you here now. Okay, so it says the sine of 60. Sine means opposite over hypotenuse. So that would mean we're actually taking the square root of 3 over 2 over 1. Well, isn't that just really the square root of 3 over 2? Exactly. So we're just going to put the square root of 3 over 2 there. Now, I want to bring to your attention that if you guys do the sine of 60 in your calculator, you get 0.8660. Okay? And if you do the square root of 3, enter in your calculator and divide that by 2, you get 0.8660. So you can check it this way, okay? Now, cosine of 60, if you do the cosine of 60 in your calculator, you're going to get 1/2 because cosine means adjacent. So isn't the 1/2 adjacent to the 60-degree angle? It is, okay? So now when we talk about the sine and cosine of the 45-degree angle, this is going to be a, let's just do this with a, we're going to do a 45, 45, 90, okay? So this is 45, and this is 45. And again, our hypotenuse is going to be 1, okay? So if that's 1, and the formula is h is equal to L square root of 2, right? So if this is 1, okay, and our leg is equal to the square root of 2, then we're going to divide by the square root of 2 and the square root of 2, recalling that we cannot leave a radical in the denominator. So that's going to end up being the square root of 2 over 2, right? Because that ends up being 2. So this is the square root of 2 over 2, and these legs are congruent, aren't they? Because it's a 45, 45, 90. So this is also the square root of 2 over 2, okay? So that means, again, opposite and adjacent. Opposite of the 45 degrees, square root of 2 over 2. Adjacent, square root of 2 over 2. Now, again, if you do the sine of 45 in your calculator, you get 0.7071, okay? And if you do the square root of 2, enter. The square root of 2, enter, divided by 2, and your calculator, you get the same value, okay? So that's one of the things I want you to see. Now, let's look at the sine of 30 now. Sine means opposite, right? So when we're talking about the opposite, again, of the 30-degree angle, this is going to be our 1/2, right? And the adjacent is going to be the square root of 3 over 2, okay? So once again, you can do these in your calculator. The sine of 30, if you do the sine of 30 in your calculator, you're going to see that it gives you 0.5, okay? So it's the same measure. All right, so on this next problem, it says, given RTUV is a rectangle and TS is 25, TU is 9, UV is 40, and QV is 1 foot. Solve for the length of SQ. So we need to find SR down here. We need to find this right here. So notice we've got this side over here, 40. So SR is what we're looking for, okay? SR is going to be equal to 40 minus 25, isn't it? So that's going to be equal to 15, okay? Then we're going to talk about QR down here. So we want to find RQ, QR, whatever. RQ is going to be equal to, notice that this is 9, and that right there is 1. 9 minus 1 is equal to 8. So isn't this a right triangle now? Yes. So this is 15 over here, and this is now 8 there. So we're just going to find SQ by doing a squared plus b squared equals c squared, and that's our c, right? So we're going to do 15 squared plus 8 squared, and that's going to be equal to our SQ squared. So when I did this, I got 225 plus 64 is equal to SQ squared. That was 289 is equal to SQ squared. So we're going to take the square root of both sides, right? Because we don't want SQ squared, we want SQ. So that means SQ is equal to 17. All right, so the section says, which point is on the circle with a center of 4, -2, and a radius of 4. So this is our h, and this is our k, and this is our r, right? And we're going to use the equation x minus h squared plus y minus k squared equals r squared, okay? So we're just going to plug in the values that were given. So this is going to be x minus 4 squared plus y minus a minus 2, so that's going to be plus 2. Remember, those signs are going to change. And then we're going to do our 4 squared, which is going to be what? 16. You got it. Okay, now we're just testing points, okay? So what we're going to do first is A. So A is going to be 4 minus 4 squared plus 4 plus 2 squared, and we want to know, does that equal 16? So this is going to be 0 squared plus 6 squared equals 16. Nope, this is 36. Does not equal 16, right, y'all? All right, let's keep going. So we're going to do the next one. B, same thing, okay? So we're doing again, negative 3 minus 4 squared plus 1 plus 2 squared. I can tell you right now that's not going to equal 16, right? Because this is going to be negative 7 squared. Isn't that right, y'all? That's going to be 49. So that's definitely not going to be equal to 16, okay? All right, let's keep going and let's do C. So this one's going to be 1 minus 4 squared. So that's going to be negative 3 squared. That's going to be 9. And then we've got plus 0 plus 2 squared. So that would have been 2 squared. So this is going to be 9 plus 4. Well, that's 13. And that does not equal 16 either. So we got one more, D. D. Okay, so here again, we're going to, let's see if I can see the number up here. I can't see it. So this is going to be 0 minus 4 squared. So that's going to be negative 4 squared plus our negative 2 plus 2 squared. And we want to know, does that equal 16? So this is going to be plus 0 squared. Well, this one looks like it's going to be our 1, y'all. Okay, so what we're doing here, that's equal to 16. So this is negative 4 times negative 4 is 16. So 16 does equal 16. So D is our answer. Okay, D is the answer. And that's what you're going to have to do on the test. All right, so this next one says find the volume of the following pyramid, round to the nearest tenth. So what we need is the height, right? Because the volume of a formula of a pyramid is equal to 1/3 base times height, right? Okay, so we don't have the height right now, do we? Okay, let me show y'all where the height is. The height goes smack dab in the middle of this shape, right? So across here we have a right triangle, don't we? Okay, so this is our height, and we don't have it right now. And how far across does this go? Doesn't it go to the center? So if that whole side, this whole side is 4, then isn't this going to be 2? Indeed. So I'm going to redraw that triangle out here so so you guys can clearly see it. Okay. So we said this was 2, this is 3.6, and this is our height, right? So aren't we just going to use Pythagorean's theorem to solve for the height? Yes. So we're going to do 2 squared plus 8 squared is equal to 3.6 squared. We have to solve for the height first, y'all. Okay. So when we do that, we got 4 plus 8 squared is equal to, if I do 3 point, that's 12.96. Subtract 4 from 12.96, so 8 squared is equal to 8.96. Then we're going to take square root of both of those sides. So when I did that, I got h is equal to 2.99, blah, 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 blah. Just keep that in the calculator, okay? So now our base of our pyramid is what? So look, again, we're going to do our 1/3. Our base is going to be 4 times 4, and then we're going to take that 2.99, whatever is in there. We're going to do 2.999, whatever, blah, 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 right? Times 4 and divide that by 3. Okay, so when we did that, I got that the volume of this pyramid was equal to 16. So that's centimeters cubed. Okay. All right, the next one says find the volume of a sphere with a diameter of 12 meters. Well, what's the problem with this one, y'all? Do we use diameters? No. So we have to take this and divide it by 2 to get our radius of 6, right? So this is just the volume of a sphere. That's 4/3 pi times 6 cubed, right? So 4/3 times 6 cubed is equal to 288 pi. And then when I multiply that 288 by pi, I got that it was 904.8. Both of these are centimeters cubed. Now, y'all need to really watch your answer choices because guaranteed 288 would be one of them if it said round to the nearest tenth of a meter, okay? And it didn't say in terms of pi. All right, the next one says find the radius of a cone, volume of a cone. That formula is equal to 1/3 pi r squared h. So we're given the volume, right? So we're going to do 540 pi is equal to 1/3 pi r squared times r 20, right? Okay. So I notice that there's pi's on both sides of the equal sign, so they're going to cross out, right? And the way I'm going to get rid of that 1/3 is I'm going to multiply both sides times 3, okay? When I do that, I get 1620. And that equals our 20 times our r squared. So then I'm going to divide both sides by 20. When I did that, I got 81. And that 81 is equal to r squared. So I'm now going to take the square root of 81 and r squared. So r is equal to 9. And this is feet, right? Okay. We good? All right, the next one is a square-shaped garden is being designed. A triangular region of the corner of the garden will be covered with decorative rocks as shown. If it takes 96 rocks to completely cover the triangular region, how many rocks are there per square foot? See that statement, rocks per square foot? So it means rocks are on top, feet squared are on the bottom. So our area is going where? On the bottom. So we're always talking here, things over area, okay? That could be rocks. In the next problem, it's dots. It could be people, whatever it is. It's over area, okay? So notice this is a 45, 45, 90 triangle, right? So doesn't that mean both these sides are 8? So the area of a triangle is 1/2 base times height. So this is going to be equal to 1/2 8 times 8. That's 64. Half of 64 is 32. So this is going to be 32 feet squared, right? And remember, we're taking our things, our rocks. The problem tells us how to set up the problem. Rocks, right? So we got rocks on top. So that's going to be our 96 divided by our 32. And that means 3 rocks per feet squared. Okay, let's talk about this next one. This next one says, Jessica creates a painting of sunflowers by using dots of different color paint. She counts and finds that she used a total of 460 dots to make her painting. There are blank contained in the region, okay? So it's asking us, again, to find the area. So again, our area is equal to 1/2 our base times our height. So that's going to be 1/2 of 17 times our 14. So when I did that, I got 119 centimeters squared. Now, once again, where does our centimeters go? On the bottom, because that's our area, right? We had 476 things. That's our dots, right? 476 dots divided by our 119. So that gave us, and that was centimeters squared, right? So that's what gave us our 4 dots per centimeter squared. So our answer was C. All right, number 12 says the volume of a cube is 100 yards cubed. What is the height? So remember that a side times a side times a side, all the sides are the same, right? So every edge in a cube is the same. So isn't that going to be s cubed? That's going to be equal to 1,000, okay? So if it's a cube, all your sides are the same. So how do we get rid of the third? We multiply it by 1/3, right? Or we take the third root. So this is going to be to the 1/3 power, and this is going to be to the 1/3 power, and that means our answer is 10 yards. So just remember, if it's a cube, you're going to take the cube root of it, which is this, or you're going to take it to the 1/3 power. They are the same thing, okay? Number 13 says, find the volume of a cylinder that has a radius of 3.8 and a height of 20 centimeters. Answer in terms of pi into the nearest 1/10 of a centimeter. Okay, so the volume of a cylinder is equal to pi r squared, that's our base, times our height, right? So that's going to be equal to pi times our 3.8 squared times our 20. Now you're going to have to look at the answers when you do this problem. Does it have pi in it or not? So when I did this one, I got 288.8 pi. And then when I multiplied that by pi, I got 907.3, and both of these are centimeters cubed. Okay, so first I want to talk to you all about what does it mean when it says reference angles. Okay, so we're always going to create a reference angle relative to this line right here, okay? So over on the left over here we got 180 degrees, right? And over here we got 0 or 360. So we're going to talk about our theta. Theta is theta in the first quadrant, okay? Over here you're going to do 180 minus theta to find your reference angle. Here you're going to do theta minus 180 to get your reference angle. And here you're going to do 360 minus theta to get your reference angle, okay? So in part of this is because if you notice up here, This is 90, right? Okay, and this is 270, yes? So when we start talking about where are these angles in these quadrants, it matters, okay? So on the left-hand side, you're going to do something with 180. On the right, the top right quadrant, those are your reference angles, okay? But in the bottom one, you're going to do 360 minus whatever theta is. And remember, reference angles are always positive. So we're going to talk through these, okay? So the way we are, 210 is between 180 and 270, isn't it? So it's down here, okay? So let's just say this is 210 degrees. So to find this again, we're going to do 210 minus the 180. So this is 30 degrees. That's your reference angle right there. So from there to there, it's 30 degrees, okay? Now, when we talk about the next one, which is just halfway through there, isn't it, y'all? This is 225, okay? So this is going to be 225 minus our 180 again, and this is going to be a reference angle of 45 degrees. So again, from here to there, that's 45 degrees. Okay, we got one more. So now we're going to do our 240 minus our 180, and that's going to be 60 degrees. Okay, so again, we're going to draw this one right here. This is 260 degrees, and from here to there, that is 60 degrees, okay? That's what reference angles are. Now, again, remember, if you're in quadrant 2 up here, you're going to do 180 minus theta. If you're in quadrant 4 over here, you're going to do 360 minus theta, and that's because you're closer to 360 over here, right? Because you're between 270 and 360 right there, okay? So if you're on the left, you're going to do 180 minus theta, or you're going to do theta minus 180, okay? If you're on the right, top right quadrant, those are your reference angles, okay? And these are all going to be either 30 or 60 or 45, okay? Those are the three reference angles. It'll never be 90, 180, 270, or 360 or 0, okay? Reference angles are 30, 60, 45 degree angles, okay? So here's 15. So let's talk about this one. So notice this is a radius, right? And this right here is a tangent. Okay, so where a radius and tangent come together, there's always a right angle. Okay, so that means that I could use Pythagorean's theorem to solve for this whole side right here, right? Now, something else I notice is that we have a radius of 11.4, and isn't this right here just another radius? It is. So, and isn't that green side, this whole side right here, y'all, isn't this going to be our C because it's opposite our right angle? Indeed. So what we're going to do to solve this is we're going to do 15 squared plus our 11.4 squared, and that's going to be equal to our C squared, right? So when I did that, I got 361 over here. And that's equal to C squared. Now to find C, aren't we going to take the square root of both sides? Indeed. So C was equal to 19. So that's this whole length right here, y'all, 19. So to find the question mark, which is what it's asking us to find right here, don't we just need to do 19 minus the 11.4? Exactly. So that's 7.6. So keep in mind that we have two radiuses in this drawing. And that's one of the keys to you being able to solve this problem.